Hello friends, in today's lecture we discuss part 2 of time division multiplexing from the subject Foundations of Communication and Computer Network. As we have seen, basically there are two types of time division multiplexing. First is synchronous time division multiplexing and second is statistical time division multiplexing. In today's lecture we discuss different stuffs related to statistical time division multiplexing. So when slots are dynamically allocated to improve bandwidth efficiency, we can use statistical time division multiplexing. Only when an input line has a slot with data to send, then and then only we can assign slot to the data frame and that frame can send data. It is given a slot in the output frame for that data. The number of slots in each frame is less than the number of input lines. The multiplexer checks each input line in round robin fashion. It means it allocates a slot for an input line if that line has a data to send. Otherwise, it skips the line and checks the next line. Figure shows time division multiplexing. Some slots are empty because the corresponding line does not have data to send, such as line C, and no slot is left empty as long as there are data to be sent by input line. In statistical multiplexing, there is no fixed relationship between inputs and outputs because there are no pre-assigned or reserved slots between input and output. We need to include the address of the receiver inside each slot to show where it is to be delivered. That means a slot needs to carry data as well as address of the destination in statistical time division multiplexing. The addressing in its simplest form can be n bits. To define n different output lines with the formula n is equal to log 2 of n. We'll take here example. For 8 different output lines, we need a 3-bit address. Given figure shows the comparison between time slots in synchronous TDM and statistical TDM. In statistical TDM, a block of data is usually many bytes, while the address is just a few bytes. The main difference which is shown here, even if line C does not have any data to send in synchronous TDM, there is one empty slot allotted for line C in the output frame, but in statistical TDM, line C does not have any data to send, so no any frame is assigned in output line for line C. There is one more difference between synchronous and statistical TDM is this time is at the frame level, means the frames in statistical TDM need not be synchronized, so we do not need synchronization bits. But in synchronous TDM, it is necessary to synchronize different frames, such as input and output. In statistical TDM, the capacity of the link is normally less than the sum of the capacity of the each and every channel, but in statistical TDM defines the capacity of the link based on statistics of the load for each channel. In this way, we have discussed statistical TDM and we have seen comparison between synchronous TDM and statistical TDM. Okay, thank you.